Hi students, today I would like to discuss about sensors. Sensors for sensing the measuring of acoustic fields, magnetic fields, currents, acceleration, strain, pressure, temperature, rotation, and etc. Rotation sensing can be done with the help of the fiber optic gyroscopy. So the sensors are using, it consists of light source with generate light signals. So sensors are different types: pressure sensor, strain sensor, magnetostrictive sensors, piezoelectric sensors, etc. Sensors are different type of sensors: strain sensor, pressure sensor, piezoelectric strip sensor, magnetostrictive strip sensor, bimetallic strip sensor, pyroelectric detectors, fight detectors, and applications. What is the strain sensor? A strain sensor whose resistance varies with applied force. It converts force, pressure, tension, weight, etc. into a change in electrical resistance, which can then be measured. When external force are applied to a stationary object, stress and strain are the result. The definition of strain gauge is example of passive transducer that converts a mechanical displacement into a change of resistance. A strain sensor is a thin Weber-like device that can be attached to a variety of material to measure applied strain. So from the diagrams as shown in the figures, the structure of strain sensor. So here it's apply the strain, pressure apply the opposite directions. The majority of strain gases or foil types available in wide choice of shapes and sizes to suit a variety of applications. They consist of a pattern of resistance foil which is mounted on a backing material. They operate on the principle that as a foil is subjected to thrust, the resistance of the foil changes in defined way. So in this diagram, the principle of strain working principle, the working principle is based on the strain or resistance relationship of electrical conductors. Any electrical conductor changes its resistance with a mechanical thrust. Some examples are through the tension or compression forces, the resistance change is partially due to the conductor's deformation and partially due to changes in resistivity of the conductor material as a result of microstructural changes. The operating principle: sensor utilizes bonded strain gases connected in Wheatstone bridge circuit. The output is derived from imbalance in the bridge circuit as load is sensed by the sensors. The strain gauges the measures deflection of elastic diagram due to pressure difference across the widely used in industries, used for pressure ranges and measurements of tend to drift. Second one is pressure sensor. Pressure sensor, it is usually strain in the terms of force per unit area. So pressure is equal force by cross-sectional area. The standard unit for pressure is the Pascal. The pressure sensor is a device for pressure measurement of gases or liquids. Pressure is an expression for force required to stop a fluid from expanding A pressure sensor usually acts as transducers. The transducer is a device that converts energy from one form to another form. The pressure sensor can alternately be called pressure transducers, pressure indicators, piezometers, and manometers. They may have over 50 technologies and almost 300 companies making the pressure sensors. Types of pressure sensors, they are in 5 types: absolute pressure sensors, gaseous pressure sensor, vacuum pressure sensor, differential pressure sensors, scaled pressure sensors. Absolute pressure sensor, this sensor measures the pressure relative to perfect vacuum. From the diagram, the absolute temperature, the vacuum is air adaptation, and high performance of industrial applications such as monitoring vacuum pumps, liquid pressure measurements. The gaseous pressure sensors, the sensor measures the pressure relative to atmospheric pressure. The example of tire pressure gases is the best example of gases of the pressure sensors or pressure measurements. Vacuum sensors or vacuum pressure sensors. This term can be caused the customization. It may be used to describe a sensor that measures pressure below the atmospheric pressure, showing a difference between low pressure and atmospheric pressure. A differential pressure sensor, this sensor measures the difference between two pressures, one connected to each side of the sensor. The differential pressure sensors are used to measure many properties such as pressure drops across oil filters or air filters. A scale pressure sensor, this sensor is similar to gaseous pressure sensors, except that it measures pressure relative to some fixed pressures rather than the ambient atmospheric pressures. Applications of pressure sensors, this is useful in weather instrumentation, aircraft, automobiles, and any other machinery that has pressure functionally implemented. And altitude sensing, this is useful in the aircraft, rockets, satellites, weather balloons, and many other applications. Load sensing, this is used for pressure sensors in conjunction with the Venturi effect and measure of the flow of the liquids. Leakage testing and pressure may be used to sense the decay of the pressure due to system leak. And this is commonly done by either compression to leak using differential pressures. And bimetallic stiff sensor and its applications. So bimetallic transmitter, introduction, history, principle, construction, working, advantages and disadvantages, and applications. The accurate measurement of the temperature is vital across a broad spectrum of human activities, including industrial processes, manufacturing, monitoring in food transport and storage, health and safety. Thermometer, the word thermometer comes from Greek word thermos meaning hot and meter meaning measure. The thermometer is a device that measures temperature or temperature gradient. A thermometer has two important elements: a temperature sensor in which some changes occurs with the change in temperatures. Some means of converting this change into numerical values. The temperature scale, for example, 0 Kelvin in Celsius minus 273.15 degrees centigrade, and Fahrenheit is minus 459.67 Fahrenheit degrees. For example, in Kelvin is 273.15 Kelvins, it is called 0 degrees centigrade, 32 Fahrenheit. and 373.15 kelvins, 100 degrees centigrade, 212 Fahrenheit degrees. The water boiling temperature is 100 degrees centigrade or 212 Fahrenheit or 373.15 kelvins. Bimetallic thermometer. In industry, there is always need to measure and monitor temperature of a particular spot, field, or locality. The industrial names given to such temperature sensors are temperature indicators or temperature gauges. All these temperature gauges belongs to class of instruments that are known as bimetallic sensors. The history, the earliest surveying the bimetallic strip was made by the 18th century clock marker John, who is generally credited with his invention. His earliest example had two individual metal strips joined by ribbons, but he is also invented the later technique of directly fusing molten brass into steel substrate. The working principle is two basic principles of operating is to be followed in the case of bimetallic sensors. A metal tends to undergo a volumetric dimensional changes according to change in the temperature. And different metals have different coefficient of the temperatures. The rate of volumetric change depends on the coefficient of the temperatures. So from the diagram, it changed the coefficient of the temperatures. Construction, the device consists of a bimetallic strip of the two different materials, the metals. Each metal of the thermometer has different thermal expansion coefficient. They are bonded together to form a spiral or twisted helix. Both these metal are joined together at one end by either welding or riveting. It is bonded so strong that there will not be any relative motion between the two. Spiral strip bimetallic thermometer. So if the temperature increases, automatically it is the stiff metallic strip is called enhanced. So that is called bimetallic strip. So this is type of the thermometer is used for measuring the ambient temperature because of the thermal expansion property of the metal. The deformation occurs in the spring that the variation of the temperature, the pointer and dials attached in the spring, which indicates the variation of the temperature. If the temperature gradually increases, the strip is also increases. Helical type bimetallic thermometer. The helical type bimetallic strip is mostly used for industrial application. The free end of the strip is connected to the pointer. The depletion of the strip shows the variation of the temperature. If the temperature is gradually, it is changes. Metals used in bimetallic strip: high expansion, yellow brass, nickel, low expansion, alloy of nickel and iron, Advantages of the bimetallic sensors. The bimetallic thermometer has a good accuracy. Wide ranges are available. Cost is very low. They are fully mechanical device, no need of power sources. These thermometers work best at a high temperature. And disadvantages is they are not recommended for temperature above 400 degrees Celsius. When regularly used, the metallic strip may permanently deform, which in turn will introduce errors. Their sensitivity and accuracy is less at low temperature. Thank you.